Hello everyone, welcome to second video of talking with your inverter. Uh, Principally, this video is all about Arduino tips. I will be talking about files and folders and how the newbies can start with Arduino, how to use tabs. I will talk about Arduino boards. This is all my experience. So when to use software serial, when to use hardware serial, variables, board limitations, and the Arduino IDE, the environment, how to customize that with changing the commands color, displaying number, saving when verifying or uploading, and how to change font style and scaling for better visibility. So let's get started. First of all, for the new ones who are new to Arduino, I would suggest all of you to please go and find this guy, Paul, at YouTube. I have learned Arduino from him. I hope that you will benefit from him also. And he will take you through Arduino step by step very smoothly. I'm not marketing him. I am just someone who has learned from him, and I found him to be very, very effective. He's a very good teacher. You don't realize that you are actually learning sort of C++, but by the end you end learning from him. So it's all about C++. So it's very simple. He's a very good teacher, and I suggest you, if you don't want to take all the lessons, at least first 19 lessons would be very relevant if you want to convert your standard inverter to some intelligent inverter, and you want to talk about with your inverter. So let's talk about files and folders. You must remember that in Arduino, the extension is INO. So let me show you of my folder, one of my folder. So this is, you can see in the documents Arduino, and this is now 32 inverter Q2 out. This is the folder, this one. And you can see whatever the name of the folder, you have the same file name .ino. So the folder name and your main file for Arduino should have the same name, right? So this is something you need to remember when you are going to download some files from the net. They may have some additional alphabet or the word master with them. You have to delete that word. The folder and the main file name should be the same. The file name has extension of .ino, but this .ino you can see is with other files also. So the main file must have the same name as the folder. So if I go back to, okay, so what the second tip is, if you open the main file, it will open all the related files. For example, let me open up this file, now 32 inverter Q. This is Arduino IDE. You must have learned already from the Paul videos. And open Sesame is taking time. So if you can see, so I have this file now 32 inverter Q2 out, and then there are tabs: AB send, Y setup, loop, functions, and CRC check. So all these are here. So if I go back to my folder, you can see all the other files are available. But if I open the main file, the other tabs or the files open automatically. Likewise, if I save this, if I press Ctrl S at any tab, the whole set gets saved, right? So this is the tip, and I have learned this with some difficulty. So what else I need to share with you on this account is that uh, I want to talk about tabs, right? So, but on the tabs, these are very helpful when you have long codes, like you have like 500 lines code, and it is difficult to track everything. So the tabs are saved as INO files. We have already seen these are the INO files. So if I go to my tab, so this is the drop down menu. From here I can add a new tab, and see, let's say I name it like double A, nice try. Okay, so you can see it is automatically adjusted according to the alphabet, and I have a new page, new tab in my program. So how this gets executed or compiled, it is like first the first tab will be read, then the second, then the third, then the fourth, and then the fifth. So it works like that, and the name of the tab automatically put it at the right place alphabetically. So the tip is use tabs if you have bigger program, and mm, don't avoid extensions in the tab names. Just use the name, standard name, and avoid extensions, especially like .h or .html or any other extension. And try to use this double A and double B scheming. So if I take you back to my main Arduino IDE, you can see with the help of double A, AB, capital Y, small a, I have good control over the tabs where it will fall. So, and I will suggest that instead of using double A, AB, AC, AD, try to put some gaps. Like after double A, after double A, there should be a tab with AM or AN. After that, there should be double B or double C, so that if in future while coding you need to add another tab, you will have a gap. You will have some space to add a tab. Right. So I've talked about leaving gaps. Okay, one thing. If you want to, I have learned also that if there is a function that you are going to use in your setup procedure, then that function must come before setup procedure. And if you have multiple tabs, so it should be in a tab that comes before setup tab or the function. So so this is it. You can have functions that are being used in the loop after the loop tab, but the functions that are being used in setup, that should come before setup tab or the setup procedure. Okay, so let's move forward to the next step. Okay, it's time to talk about Arduino hardware. This is, you can see some collection of my Arduino hardware. I'm going to take you through, you can see I have ordered a lot of them. I have tried a lot of them. I'm not an expert, but as a hobbyist, I can share my experience with you, what they are and what they do. So first of all, this is, you can see this is UNO, normally called Uno, Arduino Uno, and on the right side, this is Mega. So basically, they both have the same chip. They both are 16 megahertz, and it's my understanding that they are the original Arduino. This Arduino started from these boards, and the differences between the size and the number of pins. If you can see, the Mega has more pins. For example, I think they are about 54 or 55 pins that you can control, and GPIO pins, and principally the processor is the same, or there may be a difference between some RAM, maybe Uno has less RAM than Mega. I'm not sure about that. But what I know is that Uno has only one serial port UART. And in Mega, we have like three, I think. This is TX0, and maybe I can find, no, I can't find. I think there are three UART ports, and this is TX2, this is TX3, yeah, this is TX1. So there are like four serial ports, or the TTL ports, or the technically UART. Please don't, if you are a technical person, ignore my mistake, because I'm a hobbyist. Maybe I'm not technically correct, but there are four UART ports in Mega as compared to Uno. So they have their different usages. So let's move to next slide. This is Uno Nano, right? So this is Arduino Nano, and Arduino Nano is again much smaller, same chip Uno and Mega, but this one has a much less number of ports. So this may be due to, if you are doing a project where space is limited, or you don't want to have or the power is limited, maybe you can use this. And this is actually on the shield, so it's like looking bigger, but principally this is Arduino Nano, and you can use this on this shield also. I will talk about shields later, but and you can see that this doesn't have the DC pin, the input. So with the in Mega and Uno, you can see these power pins, which is not available DC power pins in Nano. So for this you have to use these shields which have this DC pins also. So let's move to other hardware. What we have, this is STM8. This is 8-bit processor. I haven't used it, just bought it because it was very cheap, like $1 I think, or $0.9. So maybe I will give it a try, but this is one of the options. And let's move forward. So these are the ESP8266. So this is not original Arduino. This is developed by some Chinese manufacturer. This is ESP. These are called ESP boards. So ESP boards, the special thing about ESP boards is that they have Wi-Fi built in. Right. So this is interesting. Like original Uno, they have different boards with different pin outs. This is standard development board with lots of pins. This is I think D1 mini, and this is also D1 mini. The differences of maybe of versions, and these are ESP01s. So I will talk about ESP01s a bit later. So the thing is, these are 80 megahertz. The earlier ones were 16 megahertz. They have Wi-Fi built in. They are like their memory is from 51K to 4 megabytes, and they are very cheap, real cheap. So they are replacing the original Arduino boards. Okay, so let's talk about this ESP01. This is again ESP8266, but the thing is, this one is very small. You can imagine the size with this USB plug. What the size of this? This has two GPIO pins. Again, it's 80 megahertz, and it has a built-in Wi-Fi. This is available in two models, 51K and 1 MB. That is ESP01S. And this is very cheap, less than $2. And this chip is used in generally in when we develop Internet of Things. Okay, if you want to get this ESP01, I would suggest to get this adapter. You can plug it this ESP01 in these sockets, and then you can program it with your PC. And these are the GPIO pins. You can attach wires, cables, and then with your sensors, so you can test it out from here. So if you want to try ESP01, do get this one. the one with these GPIO I/O pins and the reset button. There are some other ones, other programmable modules, but I would suggest get this one, which have this reset button and GPIO pins available on it. So let's move to next one, and this is ESP32. You can see the right one is the development board, the bigger one, and on the left side it is the mini 32. So now this is 32-bit, and this is dual core, and this is 160 megahertz to 240 megahertz. This one has Wi-Fi, Bluetooth built in, and the left one, the smaller one, I am using this as web server, and the right one I have connected with my inverter to read the data and send the commands. So you can see this is very small, and it can be used as a server. What else I need to share with you? That yeah, ESP Now, NOW Now. ESP Now is the technology that ESP has developed that I use to communicate between these boards. Go to the net and search about ESP Now. It's not about I am using the standard TCP connectivity and the router. This ESP Now technology is amazing. It can send, I think, about more than 100 meters. You can send and receive data in an open environment for more than 100 meters, maybe more than 500 meters. Just go and check it out, ESP Now. So I'm using this to transfer data between these boards. Okay, I hope that this information about the hardware will help you out somehow. This is what I have learned so far. And okay, so this is STM32 board, another Arduino based board. This is used in 3D printers, and you can see these are the so this board can control 6 stepper motors at one time, and these are the power supply modules. And you can attach a screen with this jack, and this is amazing technology that even my current 3D printer has is based on Arduino Mega, that is 16 megahertz, but I'm planning to upgrade it to from single color to multicolor. So I have got this board not yet used and implemented, but this is again Arduino for my this is version 2. I'm using version 1.2 in my telescope go-to solution. So these are very good boards. So again, this Arduino is getting powerful from $1 to, I think this is more than $25, but there is a huge capability that is available with Arduino. You have a choice of capacity and power. So let's move forward to our next slide. I will now talk about shields. So in this picture, you can see that there is an Uno board, and on top of that we have this another board that is attached, and then you can see that there is again expansion slots. You can add more boards to it. This is how Arduino builds up. So you have a basic board, then you build up another board, another board, another board, and deck by deck, board by board, you built up Arduinos. Let me show you my shields. This is the driver board. See, this is called, I think, CNC shield. Yeah, this is the CNC shield. This is put over UNO board, and this is a screen. I think this is 2.8 inch screen. I can use it over my Uno board, and wow, my Uno has a display. So this is very interesting stuff, and this is how it is built. The shields are used. So if someone talk about shields, you should know that shields are the additional features you can add to your Arduinos. Okay, but there is another interesting board. I have ordered this, I have not received it yet. This is ESP Uno merger, right? So now what is coming out is a board like this with a Wi-Fi ESP built in, so that you can use the Arduino shields with ESP also. So I have ordered this, not received, and you can see the price. It's very cheap. This is AliExpress prices. So this is very cheap, and I hope to get this and use my screen with this to develop a inverter dashboard or display of my own. So I think this was it with the hardware. Yeah, so this was with the hardware I wanted to share with you. I also suggest that instead of starting with standard Uno, you should get this board and start with this, because once you learn Arduino, you will understand that Uno and Mega get obsolete very soon and you need more power. So Wi-Fi is the thing that you need to have most of the time. So I suggest it's just a suggestion, and you can choose the board as per your project needs. So something you need to understand that there is a board manager for every board, right? So you can go through the videos on the net and how to install the board managers, and you can see I have the Arduino AVR boards, the Uno, and there's Mega, and then I have this ESP32 boards, and you can see there it's not only one board. ESP32 has lots of variants. Likewise, standard Arduino has lots of variants. So you have to choose the board type according to the hardware you have. So every board, you need a board manager for each different board. And remember one thing, there are different libraries for each type of board. For example, when I say type means ESP8266 is one type, ESP32 is another type, and standard Uno, Mega, Arduino is another type. So one library that works with Uno may not be working with ESP8266, and even ESP8266 and ESP32 have different libraries. So you need to remember this, and you need to install the libraries accordingly. What else you need? There is another tip. I have been confused by these libraries for a long time. At the end, what I did was that I created different logins for different type of board. So that was user types. I have one user in my Windows that is ESP32. Another one is ESP8266, and in that login I have installed only one board type. So that there is no confusion, and the libraries don't get any conflict, because it was very difficult for me to find the errors when generated by the libraries, and I resolved them by creating different users, and in each user I have a specific library. Okay, the second thing I would suggest that is always use standard library. Try to find what is the standard library. If I go back to Arduino IDE in the tools, you see there is manage libraries. So if I go to manage libraries, there will be where it is, yeah, here it is. So this is the library manager, and try to find your library from this manager instead of downloading the library from the GitHub or from any other site and then trying to manually install it. Forget about it. Try to find the name of the library from the source and search from here and install from. So this is another tip. Otherwise you will face many problems. Okay, time to move to next tip. Okay, then there is a confusion in pinouts. So you need to understand that the pin number mentioned on the board is not necessarily the same pin number that you are going to use in your code. For example, in this is I think ESP3266 development board. If you can see, this is digital 4, but this is principally GPIO2. So if you attach a sensor on any equipment with this GPIO port and you refer it to D4, actually you are referring to digital pin number 2. So you need to understand that the numbers printed on the board may not be the right numbers you need to refer in your code. So you need to get pinout diagram of your board from the net, and you need to understand which is the actual number of the pin that you have your sensor or equipment attached to. All right. So next is the problem of hardware serial versus software serial. You see, in Arduino Uno, all we have is one UART or the hardware serial. So in Uno, we are forced to use software serial. So I use GPIO pins, 2 GPIO pins for input and output. That's simple. I invoke the software serial library and use them. There is no problem. But the problem I faced was when I moved from Uno to ESP32 boards, the software serial started giving me garbage. There was some text received from the inverter. I was using this GPIO 17 and GPIO 16 as software serial, and there was a lot of garbage coming in, and I used CRC controls, and it was like 10 replies. Out of 10 replies, 9 would be corrupt. Only 1 would be perfectly received. So that was a big of hindrance. And then I realized that even this GPIO 17 and 16, this board has UART2, TX2, RX2 serial port 2. So I use the same ports, same pins, but instead of software serial, I use them as hardware serial. As soon as I shifted from software serial to hardware serial, the garbage was gone, and 10 out of 10 replies were perfectly correct. So this may be because of the Bluetooth and Wi-Fi frequencies around these pins. This may be the because of that. I don't know. I'm not sure why it was, but I would suggest if you have a additional hardware serial available in your board, use that instead of using the software serial. Try to use the hardware serial. You can use the only one port, the UART in Uno as hardware serial while communicating with your inverter, but I have found that when you are coding, you need to track your you need to debug your code. You need to track for the errors, and for that the standard serial port, the hardware serial, you need one hardware serial to do the debugging and tracking the errors. So unless you are done with your code, then you can use this only one hardware serial. Otherwise, I would suggest get a board with more than one hardware serials. So this is the tip. Let's move to next slide. What else I have to use? Yeah, the variables and the board limitations. You need to understand that Uno is 16 megahertz, and there are some RAM limitations and there are some processor limitations. I have found out that even if you are using 12%, when you upload the code, the Arduino IDE says that you are using 12% of the available memory for the variables. But when you start executing, when the Arduino goes into execution, that memory fills up very quickly, and then the boards keep on restarting itself. So try to limit use of global variables and try to understand that these boards have limited memory, and you can't be using the variables as freely you use in your PC. I'm not a programmer. I don't code very excellently, but I can code. So as a hobbyist, because I can code, I do the coding, and that coding is not very perfect and very that is effective but not efficient. So if you are someone like me as a hobbyist, so we can't be efficient, but we can be effective. So be careful about when you are using global variables. So this is something I have learned, and from when I have to move from board to board, and that is one reason why I have to split, as I show you earlier. Where is that? Yeah, no, this one, the left one I am using from as a web server, and the right one I'm using to talk with the inverter. This is because when I use this board both for talking with the inverter and using as web server, I was facing problems. There was some memory limitations, there were some interrupt limitations, sending data to the inverter at the same time and uploading the web page. So I was facing some problem. That's why I have to split it. So I know my code would not be that efficient. It would not be. It was effective but not efficient. That can be a reason. But if you face these problems, then you can think about planning the variables. Okay. Okay, I think this is the last slide, or maybe there is one more. There's something I want to share with you. You need to customize your Arduino IDE software. So you can see this is my Arduino, but you can see I have these commands. They are bold and blue, and likewise. So these are, for me, this is easy to understand. So let me take you to from where I should get this. All right, so you need to go get to this folder. This is your PC, local disk, program files. I have 32-bit software installed, so it is x86, Arduino, then library, and then there is themes. So in this folder, you need to have this theme.txt file. If you open this up, you will find at the bottom, because this is at the bottom, right? So these are the editor commands, style 1 and style 2. You need to change these values with the color of your choice, and this is blue, dark blue for me, or the navy blue for me, and this is bold. So if you change this file, then when you reopen your Arduino IDE, you will have these commands in dark blue color. So it do customize this. And what else you need to do is, if you go to file and preferences, you will find out that you can change size, font size, and you can change the interface scale. This will change even this icon style size, and you want to display the line numbers, And one more thing, and that is, if you want that Arduino will automatically save file when upload, then you need to check this button. As default this is checked, but I have unchecked it because I want to save the file when I want to. I don't want Arduino to automatically save whenever I tell it to upload the code. So let's get back to our presentation. I think I have talked about everything. So these are the tips about Arduino IDE. Do we have anything else? Yeah, there's another thing. Most of the time, when you upload your code to the board, it gets uploaded automatically. But I have faced some problems. There is one board that get the updates automatically on one PC, but on another PC, I have to press the boot button for some time. I will show a video of that to you, but why this happens, I don't know. I have no idea. But I have found out that if you have a wrong COM port, and if you have a wrong board model, that can be one problem. But but this button thing, I have learned, I don't know why this happens, that on one PC it works without pressing the button, and on another I have to press the button. So let me show you the video. And where is that? So here it is. You need to have the correct board and the correct port, and this is important. And then you press the upload icon, and this is a simple sketch. It's almost empty. It will be quick. And you can see on the right side my ESP32 development board. And once it is done, I am not pressing any button. You can see that yeah, the dots are showing that it's trying to connect with the board, but the board is not responding. So on the other system it just uploads, but here on the system it is not responding, and after some time you will see a fatal error, and that Arduino IDE failed to communicate with the board and try to upload. So this happens, and obviously I faced this problem. But let's try to upload, but this time I will press the button. Again, Arduino is compiling. Let me be quick with this video. Okay, so it's trying to upload. Now I'm going to press the boot button for some time till the connecting bar stops, and then I release it, and then Arduino IDE uploads the code. So this is that's it about it. So this was about this video, and these are the Arduino hardware tips and software tips I wanted to share. These were not available with the videos in the I learned from Paul. So these are my experience, practical experience. I hope these will be helpful for some. So till next video, bye for now.